Welcome once again to another lesson. In today's lesson, we will discuss Cramer's rule. Specifically, we will talk about Cramer's rule for 3x3 matrices. Here are the steps. Find the determinant D of the original matrix using the coefficients of the x, y, and z from the problem. 2. Find the determinant D sub x by replacing the x values, first column, with the values after the equal sign. That would be the resultant matrix, results matrix. Leaving the x, leaving the y and z values unchanged. Find the determinant dy by replacing the y values, second column, with the values of the equal sign, leaving the x and z values unchanged. Finally, find the determinant dz by replacing the z values as the third column with the values after the equal sign, that is from the results matrix. You're leaving the first and second columns unchanged, that's the x and y values. Step 5. Use Cramer's rule to find the values of x, y, and z, and the rules are x value will be equal to dx over d, y value will be equal to dy over d, z value will be equal to dz over d. Example 1. Solve the following system using Cramer's rule. X plus y minus z equals 6. 3x minus 2y plus z equals negative 5. X plus 3y minus 2z equal 14. We want to set up the system in the form ax equals b, where a is the coefficients matrix. So you see, you have to have 1, 1, negative 1 in the first row, 3, negative 2, 1 in the second row, 1, 3, negative 2 in the third row. So we're writing all the coefficients without the variables. Then we have the variables matrix, which is x, y, and z, and the results matrix B, 6, 5, negative 14. Let us look at how to find D. D is the determinant of the original coefficients matrix. That's the determinant of the 1, 1, negative 1, 3, negative 2, 1, 1, 3, negative 2. We're going to also use the signed cofactors for the first row, which would be plus, minus, plus. So what we will do, we take the first number in the first row, which is 1. So here's your 1 right here. Then we are going to strike out the row and column that 1 is in. And what remains will be a cofactor matrix, -2, 1, 3, and negative 2. We're going to find the determinant of that cofactor matrix and multiply it by 1 with a plus sign that is above it. So the plus sign is given to that one, the first one. So that you see there below, that plus 1 times the determinant of negative 2, 1, 3, negative 2. Then we move over to our next number, which is your 1 again. This one right here. All right, so let's go to the next one. This one here. And we're going to take out the row and the column that it is in, right here. And what remains will be a cofactor matrix, 3, 1, 1, negative 2. We're going to multiply that 1 by the determinant of the cofactor matrix. And the negative sign is assigned to that. So that you see the minus 1 times the determinant of 3, 1, 1, negative 2. Next step, we move over to a third number at the top, which is your negative 1. All right, so let's identify where that is. Right, negative 1 is right here. It's right there. Let's strike through the row and the column. That negative 1. And what remains will be your cofactor matrix, that is your 3, negative 2, 1, and 3. You're going to multiply that negative 1 here by your cofactor matrix, 3, negative 2, 1, 3. And the sign that is assigned to that is a plus sign, so that's why you see the plus. Negative 1 times the determinant of 3, negative 2, 1, and 3. So let's carry out that action. Notice then there how you calculate the determinants. You multiply across from top left to bottom right and subtract, multiplying the top right to bottom left numbers. That's 1 in brackets, negative 2 times negative 2, that's 1 times 3 for your first set, and minus 1, and 3 times negative 2 minus 1 times 1, plus negative 1, which is just negative 1 times 3 times 3 minus negative 2 times 1 in brackets. Continuing down, that would be equal to 1 times 4 minus 3 minus 1 times negative 6 minus 1 minus 1 times 9 minus negative 2, which is 9 plus 2 then. So that's equal to 1 times 1 minus 1 times negative 7 minus 1 times 11. That'll be equal to 1 plus 7 minus 11. That gives us negative 3. So D, the value for D, will be equal to negative 3. So D equals negative 3. All right, D equals negative 3. That's our answer for D. Right there. Next, we're going to find dx. dx is a determinant of the matrix now where the first column is replaced by your original results matrix, which was 6, negative 5, and 14. With the second and the third columns remaining the same. And we carry out a similar process. That's going to be plus 6 times the determinant of the cofactor matrix, negative 2, 1, 3, negative 2, minus 1 times determinant of its cofactor matrix, negative 5, 1, 14, negative 2, plus negative 1 times the determinant of its cofactor matrix, negative 5, negative 2, 14, 3. So it's going to be equal to 6, in brackets, negative 2 times negative 2 minus 1 times 3. Minus 1 times in brackets, negative 5 times negative 2 minus 1 times 14. And minus 1 times in brackets, negative 5 times 3 minus negative 2 times 14. So that becomes 6 times in brackets 4 minus 3 minus 1 times in brackets 10 minus 14 minus 1 times in brackets negative 15 plus 28 is equal to 6 times 1 minus 1 times negative 4 minus 1 times 13. That's going to be equal to 6 plus 4 minus 13. That gives you dx, so that's dx equals negative 3. dx equals negative 3. Let's go down to dy. In dy, we're replacing now the second column with the original results matrix. So then dy will be the determinant of 1, 6, negative 1, 3, negative 5, 1, 1, 14, negative 2. So that's going to be a plus 1 times the determinant of its times the cofactor matrix, which is negative 5, 1, 14, negative 2, minus 6 times its cofactor matrix, determinant, 3, 1, 1, negative 2, plus negative 1 times its cofactor matrix, 3, negative 5, 1, 14. That becomes equal to 1 times in brackets, negative 5 times negative 2 minus 1 times 14. Minus 6 times in brackets, 3 times negative 2 minus 1 times 1. Minus 1 times in brackets, 3 times 14 minus negative 5 times 1. That will be equal to 1 times in brackets, 10 minus 14, minus 6 times in brackets, negative 6 minus 1, minus 1 times in brackets, 42 minus negative 5. It's going to be equal to 1 times negative 4 minus 6 times negative 7 minus 1 times 47. That becomes equal to negative 4 plus 42 minus 47. So now dy is equal to -9. dy equals -9. And so we continue now, going down to find dz. dz is the determinants of the matrix with the third column replaced by the original results column, 6, -5, 14. That will be equal to +1 times determinant of -2, 5, -5, 3, 14, and -1 times its cofactor matrix, 3, -5, 1, 14, plus 6 times its cofactor, determinants 3, -2, 1, 3. So that becomes equal to 1 times in brackets -2 times 14 minus -5 times 3 minus 1 times in brackets 3 times 14 minus 5 times minus -5 times 1 plus 6 times in brackets 3 times 3 minus -2 times 1. That becomes equal to 1 times in brackets -28 plus 15 minus 1 times in brackets 42 plus 5 plus 6 times in brackets 9 plus 2 be equal to 1 times -13 minus 1 times 47 plus 6 times 11. That's equal to -13 minus 47 plus 66. So then dz is dz equals 6. All right. Now we want to calculate numerical values for x, y, and z. On the formula, x is equal to dx over d. That's going to be equal to -3 over -3. So that's equal to +1. Y is equal to dy over d. So that's equal to -9 over -3. So that's equal to 3. So y equals 3. And z is equal to dz over d. That's going to be equal to 6 over -3. That's equal to -2. So our solution then is (1, 3) and -2 for the x, y, and z coordinates. Thank you.